cosmos for sleep stories. Tonight, we take one slow journey outward, from the ground under this room to the nearest star, and we are going to measure the whole of it in time rather than in distance. 3 days to the moon, most of a year to Mars, years to Jupiter and Saturn, nearly a decade out to Pluto, and almost 50 years to the edge of the sun's reach. And then the long crossing to the nearest star, which at the speeds we can actually travel comes out somewhere in the tens of thousands of years. Settle in and let your eyes close whenever they are ready. The journey carries on without them. It takes about 3 days to reach the moon. That is the first honest number, and it is smaller than most people expect. 3 days is a long weekend. It is a slow drive from one end of a country to the other. It is the gap between a Wednesday morning and a Saturday afternoon. And it is also exactly the distance between this planet and the only other ground that people have ever stood on. 9 crews made that crossing. They left from a launch pad in Florida, and they reached the moon 3 days later. And in between, there was very little for them to do. The moon sits a little under 400,000 kilometers away. That number is hard to hold, so hold this instead. If you shrank the Earth to the size of a basketball, the moon would be a tennis ball about 7 meters away across the room. Everything else you have ever heard of, every flight path, every ocean, every orbit that a satellite has ever been put into, happens inside the basketball's own skin. The gap to the tennis ball is the first real distance there is. A spacecraft leaves for that gap at about 40,000 kilometers an hour, and then it slows down for 3 days. This is the part that is rarely mentioned. Nothing is pushing. The engines burn for a few minutes at the beginning, and then they are finished. And the craft simply coasts uphill against the pull of the Earth, losing speed the whole way, the way a ball thrown upward loses speed. By the time the moon takes over, 3 days later, it has slowed to less than 1/10 of the speed it left with. Before any of that, though, there is a smaller step, and And it is the one almost everybody has seen a picture from. 400 kilometers up is low orbit. That is a 1-hour drive, held vertical. The space station lives there, going around the whole planet once every 90 minutes, which is an enormous speed, and does not look like one from the ground. That station has never in its life been more than 400 kilometers above the surface. Everything with people in it has stayed inside that thin band, apart from those 9 crossings to the moon. So the shape of tonight is already visible from here. The first step out is an hour. The second step is 3 days. Every step after that gets longer, and they do not get longer gently. They go from days to months, and from months to years, and from years to decades. And then, at the very end, the units change again, and the last step of the journey is longer than every other step put together by a factor no one has a good word for. There is nothing alarming in that. It is only how the map is spaced. We are going to walk out along it slowly, one honest clock at a time, out to a red plain where a spacecraft takes most of a year to arrive, out to the giant planets where arriving takes longer than a childhood, out past Pluto where a machine flew for 9.5 years to spend 1 day looking at something, out to the 2 craft that have been leaving since the 1970s and are still leaving, and then out into the gap where the nearest star is. And the honest clock there is very long, and it is quiet, and there is nothing at the other end that needs anything from us. Nothing to solve tonight. Only a distance taken slowly. Start at the moon 3 days out. You cannot leave for Mars whenever you like. The Earth goes around the Sun in a year, and Mars takes nearly 2. So the 2 of them drift in and out of convenient arrangement, and a good crossing only opens up about every 26 months. Miss one, and you wait 2 years for the next. Every Mars mission that has ever flown, without exception, left inside one of those windows. And the reason is a gentle one. You are not traveling to where Mars is. You are traveling to where Mars is going to be. A spacecraft leaving here does not aim at the red dot in the sky. It leaves along a long curve of its own around the sun, a slow outward arc, and it spends months on that arc doing nothing in particular, while the planet it is aiming at continues around its own orbit. And the whole business is arranged so that the two of them arrive at the same piece of empty space at the same time. Nobody steers. It was aimed once at the beginning, and after that it is falling. The gap itself is about 60 million kilometers when the two planets are well placed. The path is nearly 500 million. That is what it costs to go outward. The arc is far longer than the gap because you are not crossing a room. You are changing which orbit you belong to. So the honest number for Mars is somewhere between 6 and 9 months. One recent rover made the crossing in a little over 200 days. An earlier one took 250. The very first spacecraft to reach Mars at all, back in the 1960s, took about 7.5 months to fly past it and take 21 pictures. And what happens during those months is almost nothing. The craft turns slowly, a few revolutions an hour, so that no one side of it faces the sun for too long. It checks itself over. It reports home. Once or twice, on the way, it fires its thrusters for a few seconds to trim the aim. Apart from that, it is a sealed object in sunlight, going where it was thrown, with the sun getting slightly smaller behind it week by week. The talking gets slower too. At the start of the cruise, a radio message reaches home in a few minutes. By the far end, it can be 20 minutes each way. So a question and its answer are 3/4 of an hour apart. At that point, a conversation is not really a conversation anymore. It is a correspondence in letters between two places that both know the letters are already out of date. Then, after the better part of a year of nothing at all, the last few minutes are busy. Arrival is the only hurried thing in the whole journey. The craft meets the top of the thin Martian air at something like 20,000 kilometers an hour. And about 7 minutes later, it it is standing still on the ground. And every one of those minutes was decided years earlier by people who could not possibly be watching in time to help. By the time the first report arrives here, saying that everything went well, it has already been sitting on Mars for a quarter of an hour. Past Mars, the clock changes its unit. Everything from here outward is measured in years, and the reason is not really the distance. It is that going outward means climbing all the time away from the sun, and a spacecraft climbing away from the sun is losing speed for the entire journey in exactly the way it lost speed on the way to the moon. Only now it does that for a decade instead of for 3 days. Between Mars and Jupiter, there is a belt of rock, and it is worth saying plainly that nothing has ever had any trouble crossing it. In the pictures, it looks crowded. In fact, the pieces are typically about 1,000,000 kilometers apart, which is nearly 3 times the distance from here to the moon. And every craft that has ever gone that way has passed straight through without ever coming near anything. It takes months to cross, and for the whole of that time, there is usually not a single object close enough to see. Jupiter is 5 times further from the sun than we are, about 780 million kilometers. A craft that is only passing through can get there in 1.5 years. One did in the 1970s. It went by at speed, took its pictures over a few weeks, and carried straight on out of the solar system without slowing down at all. Stopping is the expensive part. To stay at Jupiter, you have to arrive slowly. And arriving slowly means you were never allowed to go quickly. The orbiter that is there now took 5 years. The one before it took 6, and it spent those 6 years going the long way round on purpose. Inward past Venus first, then twice back past the Earth, taking a very small amount of speed from each planet as it swung by. That is the trick that makes the outer solar system reachable at all. You cannot carry enough fuel, so you borrow motion from planets instead, a little at a time, and you pay for it in years. Saturn is nearly twice as far again. 1.5 billion kilometers. The the mission that went there and stayed launched in the autumn of 1997 and arrived in the summer of 2004. 6 years and 9 months. It swung past Venus twice, past the Earth once, and past Jupiter. And by the time it slid into orbit around Saturn, it had traveled about 3.5 billion kilometers to close a gap of 1.5. And then it stayed for 13 years. That is the shape of these missions, and it is a restful shape. A long, patient approach, taken at whatever pace the arithmetic allows. And then a very long, quiet residency in a place nobody will visit again for a generation. From out there, the sun is a bright point, about 100 times fainter than it is from your window. Bright enough to light the rings sharply, not bright enough to warm anything. And the radio takes about 80 minutes to cross that gap. So every instruction the craft ever received was written an hour and a half before it was needed, by people who had already gone to bed by the time it was carried out. One spacecraft was allowed to simply go. It launched in the winter of 2006 on a large rocket carrying almost nothing at all. A machine about the size of a grand piano, with no plans to stop anywhere. It left the Earth faster than anything has left the Earth before or since, at about 58,000 kilometers an hour. It passed the moon in 9 hours. The crews who made that same crossing took 3 days. This one was through and gone before the end of a working day, and it kept that pace outward. And 13 months later, it swung past Jupiter and took a little of Jupiter's motion with it, which lifted its speed again and cut 3 years off everything that followed. And then it went quiet for 8 years. This is the part of the story that suits tonight. For most of that cruise, the spacecraft was deliberately asleep. Its instruments were powered down. Its computer was doing almost nothing. And it traveled on with a single steady signal going home, so that anyone watching for it would know it was well. It was woken a couple of times a year for a few weeks, checked over, exercised, and put back to sleep. Something like 18 separate naps, adding up to about 5 years of the 9. And for almost all of those 9 years, the place it was going to was not a place. It was a smudge. The best picture anyone had of Pluto when that spacecraft launched was a handful of soft pixels, a pale blob with slightly darker regions on it, and no one could say what any of them were. The whole point of flying for 9.5 years was to find out whether that blob had mountains. Then, in the last few weeks, it began to grow in the camera, a little more each day, from a dot into a disk, into a world with a pale, heart-shaped plane on one side of it. It arrived in the summer of 2015, 4.5 billion kilometers out, 9 years and 5 months. And it could not stop. There was never any question of stopping. Stopping would have needed more fuel than could ever have been launched. So after 9.5 years of travel, it flew past Pluto at about 14 kilometers a second and kept going. The part where Pluto filled the window lasted roughly a day. The closest approach lasted minutes. Then came the slowest part of the whole mission. At that distance, the radio signal takes 4.5 hours to reach us, and the transmitter is faint. So the pictures came home at about the speed of an old telephone modem. The spacecraft had to read out everything it had gathered in that one day slowly, over and over, for the next 15 months. The last of it arrived more than a year after the encounter was over. There is something restful in that too. The flyby was finished long before the pictures were. The craft is still out there, still moving at 14 kilometers a second, well past Pluto now, through the wide, flat ring of ice and rock the outer system is made of, with its transmitter on. The fastest object people have ever made is not going outward at all. It is a small craft with a thick shield on the front of it, and it is falling toward the sun. At the bottom of that fall, it moves at about 190 kilometers every second, roughly 690,000 kilometers an hour, fast enough to cross an ocean in the time it takes to say so. But that speed is borrowed, and it is borrowed briefly. It has fallen a long way inward to get it, the way anything falling gets faster near the bottom. And it holds that number for a matter of minutes before the climb back out takes every bit of it away again. That craft is not traveling anywhere. It is doing laps of a hill. Going outward is the opposite arrangement. Everything we have sent outward was thrown once, at the beginning, by chemical rockets. And a chemical rocket has to lift its own fuel. So most of what stands on the pad is propellant, whose only job is to accelerate the propellant above it. That is the whole ceiling, and it has not moved much in 50 years. It buys a few minutes of push, and after that the craft is a thrown object. The honest outbound numbers go like this. The fastest thing ever thrown out of the solar system is moving at about 17 kilometers a second. The Pluto craft is doing about 14. Nothing people have built goes faster than that away from the sun, and nothing will until something quite different from a rocket is built. 17 kilometers a second is not a small number by any measure you have ever used. It would take you from London to New York in under 6 minutes. It crosses the width of this planet in about 12. It would cover the 3 days of the Apollo crossing in about 6 hours, and the whole 9.5 year run to Pluto in something like a decade, which is, of course, exactly what it did. It is enormous, and it is steady, and almost nothing out there is able to slow it down, because there is almost nothing out there at all. Almost. The sun still has a very faint hold, even at that distance, and it is still very slowly taking speed back, about 7 meters a second over the coming year, and a little less every year after that, as the grip weakens with the distance. Add up the whole of the rest of that journey, all of it forever, and the sun will reclaim only around 300 meters a second out of 17,000. That is the last thread. It never quite lets go, and it never quite pulls anything back. And there is one more thing about 17 kilometers a second that is easy to forget, because every number in this chapter is fierce, and none of the experience is. You would feel nothing. There is no wind at that speed because there is nothing to blow. No shaking, no sense of rushing, no horizon going past. Once the engines have stopped, a spacecraft moving faster than anything humans have ever moved is simply floating, absolutely still as far as it can tell, with nothing close enough to measure itself against. And the distance ahead of it is very large and very quiet and in no hurry at all. 2 spacecraft left in the summer and autumn of 1977. They have been traveling ever since, not orbiting, not waiting, leaving continuously for almost 49 years at about 17 kilometers a second, which is the fastest anything has ever gone away from here. The first of them crossed the edge of the sun's reach in 2012. That is 35 years of flight to get to the boundary. And the boundary is not a wall or a line or anything you could photograph. It is simply the place where the thin outward flow of particles from the sun finally comes to a stop against the material drifting between the stars, and the sun's influence hands over. There is no moment. The instruments noticed the change over several weeks. Its companion crossed the same boundary 6 years later, at almost the same distance out. They are now something like 25 billion kilometers away, and a radio message takes nearly a day to reach either of them. Their transmitters put out about as much power as a refrigerator light. We can still hear both of them. What they travel through now is not empty, though it is close to it. The material between the stars is a thin haze of hydrogen, so thin that a space the size of a sugar cube might hold a single atom, and very often holds none. A better vacuum than any laboratory on Earth has ever made. That is what the rest of tonight's journey is made of. It carries on at about that thinness for light years in every direction. Neither craft is aimed at anything. They were pointed at planets, and the planets sent them onward, and where they go now is simply where that left them. Still, in about 40,000 years, one of them will pass within a couple of light years of a small dim star, closer to it than we are to Proxima. It will not stop, and nothing will notice. And by then, it will have been drifting for roughly 800 times as long as it has already. And here is the part worth sitting with. That is not the edge of the solar system. Not really. The sun's gravity keeps hold of things very much further out than its wind does. And somewhere out there, far past anything we have ever visited, is a wide, sparse shell of drifting comets wrapped around the whole of the sun's holdings, so far out that each of them takes millions of years to make its one slow circle. The first of those two craft will reach the inner edge of that shell in about 300 years. It will take it something like 30,000 years to pass through and come out the other side. The accounting, after all of that flying, is not a disappointment. It is only a measurement. Almost 50 years of the fastest departure ever achieved by the two most traveled objects in human history has carried them about 1/400th of a single light year. 1/400th. They are doing exactly what they were built to do, and they are doing it beautifully, and they will carry on doing it long after everything that was ever written about them has been forgotten. The nearest star is 4¼ light years away. That is about 40 trillion kilometers, which is a number with no useful comparison in it at all. So put it in the units we have been using. It is roughly 270,000 times the distance from here to the sun. It is about 1,600 times further out than the two old spacecraft have managed to get in half a century of leaving. Its name is Proxima Centauri, and you cannot see it. That is the first surprising thing about the nearest star. It is a small, cool red one, about 1/8 the mass of the sun, and so faint that no one on Earth has ever seen it without a telescope. It was not even noticed until a century ago. The closest star there has been quietly invisible for the whole of human history. It keeps company with two brighter stars, close by its own standards, and those two you can see. From the southern half of this planet, they sit low and steady and look like one single bright point. Proxima goes around that pair at an enormous distance, one lap every 500,000 years or so. Those two are worth a moment. Because of all the stars in the sky, they are the least strange. One of them is very nearly a copy of our own sun, almost the same size, the same yellow, the same steady output, close enough that if you swapped the two of them, it would take instruments to notice. The other is a little smaller and a little more orange, and they go around each other slowly, close enough that from anywhere else they blur into one. The nearest thing to us in the whole universe is an ordinary arrangement of ordinary stars, doing nothing remarkable at all. And Proxima has a planet, a world a little larger than this one, going around that small red star once every 11 days. At 17 kilometers a second, the speed of the fastest departure ever made, the crossing takes about 75,000 years. If you could somehow hold the speed of that craft falling toward the sun, 190 kilometers a second, the whole way, it takes about 6,500. 1% of the speed of light, many times beyond anything ever built, though it has been sketched on paper more than once, brings the crossing down to about 420 years, long enough that whoever released it would never hear how it went. Those are the honest numbers, and there is no trick that makes them smaller. One more thing about that star, and it is a gentle one. Proxima has only been the nearest star for about 32,000 years, and it will hold the title for roughly 25,000 more. The stars all drift. Another one is slowly coming closer, and in time it will take over, and nothing about that arrangement was ever meant to be permanent. Even nearest is a temporary condition. One traveler makes the crossing on a reasonable schedule. Light goes 300,000 kilometers every second, and it does it without carrying fuel, without slowing down, and without any of the arithmetic that has made every other number tonight so long. It is the only thing in this entire journey that that is not climbing uphill. Light makes the same journey on a different clock. The moon is 1.33 seconds away. If you stood on the shore of a lunar plain and someone here spoke to you, the pause before each reply would be about the length of a breath. The sun is 8 minutes and 20 seconds away. The light coming through the window this afternoon left the surface of the sun before you thought about the afternoon at all. Jupiter is about 40 minutes. Saturn is about an hour and 20. Neptune, out at the far edge of the planets, is around 4 hours. So the outermost planet in the solar system is a working day's light away, there and back. The two old spacecraft are nearly a day, and the nearest star is 4 years and about 3 months, which means the sky, all of it, is a set of photographs taken at different times and delivered tonight. Nothing you can see up there is current. The bright point low in the south is 4 years old. The brightest star in the whole sky is 8.5 years old. So its light left before some of the people looking at it could walk. The faint smudge of the next galaxy along is 2.5 million years old. It left before there was anybody here to look at it, and it has been on its way the entire time, unhurried, at the only speed it has. This is true much closer in as well, and always has been. The far wall of the room you are in is a few billionths of a second old. The hand at the end of your arm is a fraction of that. Nothing anywhere has ever been seen as it is. Everything is seen as it was, and the only thing that changes with distance is by how much. On a table, it is nothing. At the moon, it is a breath. At the nearest star, it is 4 years. Nothing about that is a problem to be solved. It is only the speed at which the news travels, and the news has never traveled any faster than this. And everything alive has spent its entire existence perfectly comfortable inside the delay. And it works both ways, which is the part worth taking to sleep. If someone stood on that planet around Proxima tonight and looked back toward us, they would not see anything they had to think about. Just an ordinary yellow star, one of the nothing more than that, sitting in a constellation that from there has a slightly different shape than it does from here. And the light they would be looking at left this planet 4 years ago. It is already most of the way there. Nothing out there is hurrying. The two old craft will carry on outward, exactly as they have every second since 1977. The Pluto machine will keep drifting through the ice. The small red star will sit 4.25 light years away, where it has been the whole time, in no particular hurry to be reached. There is nothing left to follow, only the long way out, going on quietly in every direction at its own pace. Sleep well,